The liver is the human body's largest inner organ and fulfills a number of complex functions. About 1 in 4 adults in the Western world suffer from fatty degeneration of the liver, most often caused by alcohol abuse or viral hepatitis. Various other diseases can also cause fatty liver. Fatty liver and hepatitis often progress to cirrhosis. In liver cirrhosis, many liver cells die, and as a consequence, the organ's capacity for detoxification is impaired. Frequently, cirrhosis of the liver leads to hepatic encephalopathy. The symptoms are attention deficit, confusion, and a characteristic flapping tremor. In severe cases, it can lead to coma. Hepatic encephalopathy is the result of a pathologically increased level of ammonia. The diseased liver is no longer able to remove it. In hepatic encephalopathy, ammonia accumulates in the brain, where it damages astrocytes and disrupts communication between brain cells. Where does the ammonia come from? It is a normal breakdown product from the degradation of proteins in the intestines. Via the bloodstream, it is distributed throughout the body. Detoxification of ammonia normally occurs at 3 sites, mainly in the liver, but also in muscle cells and in the astrocytes of the nervous system. But only in the healthy liver, in the periportal hepatocytes, is ammonia converted into non-toxic urea. This happens in the course of the physiological urea cycle. In the perivenous hepatocytes of the liver, remaining ammonia is converted to another non-toxic agent, glutamine. Like the perivenous hepatocytes, muscle cells and the astrocytes in the brain are also able to remove ammonia by converting it into glutamine. If the liver cells are damaged or their number diminished, lasting detoxification by transforming ammonia into urea is disrupted. The ammonia content in the blood rises, and soon the other 2 systems for removing ammonia are also stretched beyond their limit. As a consequence of the increased levels of ammonia, many nerve cells in the brain are unable to communicate with each other. Hepa-Merz by Merz is used for the management of hepatic encephalopathy. The active ingredients it contains are the 2 amino acids L-Aspartate and L-Ornithine. Ornithine and aspartate are endogenous substances and play an important role in the urea cycle. The urea cycle uses aspartate and ornithine for the conversion of ammonia into urea. Administration of these 2 amino acids enhances the detoxification performance of the urea cycle in the remaining liver cells. Toxic ammonia is now increasingly converted into urea. As substrates, ornithine and aspartate also increase the synthesis of glutamine. Both are very suitable starting substances for the synthesis of glutamate through transamination. As a result, more glutamate is available to be transformed into glutamine. This process happens in the residual perivenous hepatocytes, but mainly in the muscle cells. Because glutamine has anabolic and anti-catabolic effects, it can help prevent the loss of muscle mass often associated with a malfunctioning liver. Administering Hepa-Merz boosts 2 different processes of detoxification of ammonia: the synthesis of non-toxic urea from toxic ammonia in the remaining hepatocytes, and detoxification through synthesis of glutamine in the muscle cells. This dual effect of Hepa-Merz decreases the content of ammonia in the blood. Uptake of ammonia by the brain decreases, the symptoms of hepatic encephalopathy recede, and the patient's quality of life improves. Hepa-Merz, for the treatment of chronic liver diseases and their neurological complications.